Next interesting problem, that is 22, we'll try to solve the palindromic substrings. The problem is that, so given a string and return the possible palindromic substrings within the given string. Example, we'll take ABC. So here we can take A is a one of the palindromic substring. B is all individual characters are like palindromic substrings. Similarly for A is one palindrome, next A and one more substring A. All individual characters are like palindromes, and AA like the other combinations also like a palindromic, and complete uh, string also like a palindromic. Palindromic is nothing but you from left to right and right to left should be same string. Correct. So try to understand different solutions for this. Let us take the string. Let's try for brute force approach. So for example, you have ABC is the string. So what we need to do is we need to take all the strings, all the substrings. It will take like a two for loops. One for loop try to take the all the all the combinations of the this particular entire string. So you will get AB, ABC. This is the first set of strings. In this set, actually, you will get the A is only one uh, palindromic substring, and remaining two are not. And next iteration, we can take B and BC. In this also only we have B is the one substring which is actually palindromic, and similarly remaining character is C. This is again palindromic. Okay, so you will get 1 2 3. 3 is the output. This is the brute force. Basically, to split all these substrings will take the O of n square time complexity, and to validate but this particular substring is palindrome or not, again this will take O of n time complexity. Okay, so the total will be like a big O of n cube time complexity to validate, to get all the palindromic substring out of this string. Okay, so this is the brute force thing. Also we can just try to see the another string whatever the mention. So in this AAA second example, first we'll take about A is one character, is a palindrome, and AA the next substring, this is also a palindrome, and A A this is also palindrome. So from here we are done. Next substring will take. So next substring will be again A, right? This is also one. Um, this is also one palindrome, and remaining A. This is also one uh, palindrome. So we covered all this substring. Then remaining substring is A. This is also a palindrome. Okay. So total 6 you can return from this one. This is again brute force. Again this will take for splitting one square, and to validate the given substring is palindrome or not with O of n time complexity. This total will be big O of n cube. Okay. This is the brute force approach. Let us see for let us check for optimized solution. Again we'll take optimized solution could be like we'll take ABC, right? So basically what we can do is we'll try to see um, from A, okay, and then we can try to check basically like how many combinations these things will happen, that we can check. That is actually 2n minus 1, basically 2 into n combinations will happen. Length of the ABC is like a n, right? So what we will do is we will try to take the this string, and then we'll try to move from left. We'll try to check the left position will be like, this will be, we will treat this particular position as a center, and this center is 0, 0 by 2, we'll take it. And then right will be like right position will take from the left, plus again in the first case 0 by 2. Okay, so from now we will see like this left is like a greater than or equal to 0, and right will be less than n. We'll traverse that and then see these things are possible or not, or both are same or not. For example, let us see this take will take L will be like a 0 and R also like a 0, right? Now L is greater than 0, R also less than n, so that what we can do, we can see that position A basically like a string of left and string of right are same or not. Yes, in the first case this condition will execute, and also L is greater than or equal to 0 and R also less than n, right? In this case, like a written like a number of palindromes will be 1, and we will decrement this particular thing, we'll go back and we will increment this thing, right? Once next iteration what happened, left will be like a minus, right? It will be 0 to minus 1, and this will be plus 1. So this condition will fail, means left should be greater than or equal to 0. Then we will go back and we will try to increment the B. Okay, now we will get the I value, I mean center will be like a, this is 1, left will be 1 by 2, that is again 0, and right will be 0 plus 1 by 2, right? So again like we will, sorry, this will be like a mod 2, so that we will get right will be 1 and left will be 0, right? Then we will take these two combinations and try to iterate same way. So this case actually AB it will fail because there is a mismatch. So we'll increment and we'll come back. Actually again we'll try to take the all the combinations and we'll try to see that. So accordingly we'll take the things. So this will be like time complexity will be big O of n square, because two loops we need for this. And the space complexity will be basically we want to base space also nothing, actually it's will go of one only, just extra variable we are using. Okay, okay, let's try to implement brute force and then the optimizer solution for this one. Okay, okay, so basically for brute force, as we mentioned, we can try to write the like a helper function is palindrome, and this will take the string s and it will return boolean variable. Okay, this we will try to solve in O of n time complexity. Okay, for I equal to 0, I less than, not required to go for entire loop because we'll use the two pointers, I plus plus, oops, sorry. So now what we can do is we need to check if s of I is not equal to s of n minus I minus 1. This is the last element. If this is not matching, then return false. It's a simple thing. And if you are able to pass all the things, then return true here. So we have the helper function to just handle the palindrome or not. Now we'll try to Basically, we need to return actually number of substrings. We can take it as a result. It will be 0 initially, and let us take the value of length of the string whatever we have again. So here we need basically two for loops to get the splitting of the all the elements like this, as we discussed earlier for the brute force. So for what we can do is when I equal to 0, I less than n, I plus plus, will traverse till that one, and will be nested for loop where j start from I and j will be less than n and j plus plus, right? Now here we can use the helper function whatever we wrote. If it is palindrome, we can use s of start from I and go with size of j plus 1, this substring. If this is the case, then we need to increment the result. At the end, we can return res. Yeah, this is the simple for understanding, right? Let us run and see if any compilation issues or something. Okay, this works actually, right? Yeah, if you see this works actually perfectly. And if you see second test case, yeah, this is how actually this will work. This way, whatever we calculated. This is very straightforward, right? Let us see for the, this is for brute force. Let's try to understand with optimizer solution with of this solution is basically uh, big O of n cube solution. Um, yeah, this particular thing will take big O of n, and these two loops basically big O of n square. Okay, combining actually and keep, that is the thing. Let us see for the other optimized solution will be, we can take result again 0, and length will be length of string, and we will take as I mentioned, we will take the center first. It will be 0, and center will be, as I mentioned, all the combinations, that is a 2n minus 1 is the maximum count it will happen, and plus plus. Here we can take left, as I told, center by 2, and right could be like left plus center mod 2. Okay, we'll get this. Now we can check the if left is greater than or equal to 0 and right will be less than n, and s of left equal to s of right. If this is the case, that means we found uh, the palindrome with that particular length, I mean that particular substring, and we can decrement the left and increment the right. So do we expand it actually, right? And then we can return res. This is basically like a, it will take maximum of n square time complexity. Okay, let me see it works or not. Mhm. Okay, let me see where it went wrong. Mhm. Center, left, left plus center. Mhm. Is greater than or equal to 0, right is less than n, and less of left equal to right, result plus plus. ABC3. Mhm. Like a O of n square. So we are minimizing O of n actually. Okay. O of n square solution. Okay. Yeah.